Hello again, my name is Andrew Sheets, and this is the longer form breakdown of the systems you saw in my previous video demonstration on ArtStation. So to start off, we'll show off the root motion used by the AI. Here you can see the model will smoothly shift between an idle, walking, and running animation in tandem with any direction that it happens to be guided in. So, for this project, I solved various problems regarding allowing the AI to use root motion. Of them, the most important that I perceived was solving the presence of motion jitter. So, in order to reduce the motion jitter produced by the model when turning left or right, I modified the minimum and maximum axis settings, as you can see here, among other smaller values regarding the interpolation, so when the wolf changes directions in-game, it will cleanly shift between animations, as you can see in the viewport. So, for the AI, here I have the behavior tree for the wolf AI. First off, we have the query filter, which will run when none of the wolves have spotted the player. They will not run because they do not have the target, because the target actor has not been set. They have not spotted the player. So, the query filter essentially determines which direction would be best for the AI to move in by using a location-based scoring system. So locations with higher scores, like those that don't go into a wall, for instance, will be the most likely chosen when the AI decides to move. However, before the AI moves in this direction, it first needs to determine whether the leader or the alpha wolf is where that is, and then move towards them. If the wolf is already the leader, then it will use the patrol location set up by the previously mentioned query filter. So, we'll ignore this last move to for the moment, and we'll take a look at where its values are set up. So here in the Howl branch, you can see that the player has been spotted, and it will then be assigned as the target actor. So I'll show you how that was set up. So in the first-person blueprint, here in the first-person character, it's using an interface so that we can check for if it is a viable target for the AI controller. So here in the AI controller, the character will be spotted by the AI perception component, and when the player falls within view, it will then confirm that the target is the player character right here, and then it will finally assign the target actor to the blackboard right over here. So then the player will be the target actor. Back to the behavior tree. So now that that has been set, we'll then check for if the blackboard key for has howled, as you can see down here, has been set to true or false. If it is false, then the AI will then activate this howl task. So, for this, I set up a blueprint interface with this very simple function, back to the NPC character, and then I added an event using the interface so that it will play a very simple animation montage whenever this event gets called from the animation, the blueprint interface. So I could add like damage or something on top of this, but for demonstration purposes, I'm just going to show off the animation montage. So to the howl task, whenever in the behavior tree, whenever the howl task has been executed, it will play the animation blueprint after it gets called here. It will then set has howled to true, and then it will then set the blackboard value to a boolean so that it can be read as true or false in the behavior tree. And then finally, the howler value of the it will set it to the AI wolf that howled, the individual one in the level. Let's see, and then they get set in the blackboard as well. So, all this to say, it essentially plays an animation and then sets up variables for the isHowler code that is over here. So this makes it so that when a wolf finds the player, the surrounding wolves will then navigate to the wolf that howled and saw the player first. Because of the way this is set up, by using the instance synced mode, if any of the wolves sees the player after wolf has howled, they will then ignore all the other move twos and then chase and attack the player. So these two will be ignored, and this one will be the primary node they need to focus on. And once they find the player, all of them, then all of these will be ignored for this. So I just want to briefly talk about the instance synced, which basically is very important because what it does is it makes it so that the other wolves in the scene, they understand that there are other wolves, and they can then understand that one wolf has howled and that they don't need to howl, and they should navigate to the one that has indeed howled. So, I will also mention that this cooldown here is for if maybe later I decide that after you are found by the wolves, maybe you can lose them, and so after you lose them, this would allow them to then howl again after a certain period of time to then call the other wolves to the play the previous code as you're saying. But that's just future plans. So now we'll go over this attack sequence or branch. So assuming that the target has been set, and it has, then this conditional loop will play, meaning that it will not go out to the patrol or the howl task. And so the start off with the task alert that will play first. This task alert is fairly simple, along with most of the codes in this branch. So once it is executed, it'll execute a move to, going towards a specific, guided by a specific blackboard key. It will finish executing. So you can see that the blackboard key that it was set to is the target actor or the player. So they will move continuously towards the player after they have spotted it. And then this attack task is just a simple version of the howl task. So basically, it will. There's a blueprint interface that has an event in the NPC character that will then be called over here in the task, and then we'll play the animation. Again, other stuff can be added later. Very simple. This wait is just so that the animation can be played and won't break and won't play too fast. So that just about does it for the AI. All of this was custom except for this move to, but it has been modified so that it can be that it works with the AI wolves rather than its original intended character. So it's been heavily modified. Let's see. Now we'll go to the scan effect, which you probably saw earlier. So I'll go to this instance. The biggest addition here was the creation of several material parameters so that various different aspects of the scan material can be modified for designers, including the overall size and speed of the pulse. So of these parameters, there are two here that can change the color of the different actors that were set in the world. So it does this through the use of a custom depth stencil value, and depending on that value, either it be 1 or 2, a color will change. A color will be assigned, I mean. And this is interesting because it can be assigned through the instance so that people making this or using it can very quickly determine what fits best with the project. So assuming that you have, maybe you don't want the enemies to be red. You want them to be green or something. You can change it here very quickly. You can do the same with the objects right here. And you can see that being set up in the main material. You can see the different material parameters being set with the various nodes in the material. So you can see here that radius will determine how far out the scan will go, and here you can see size will determine how often the texture will repeat on the scan. So whether you want large hexagons or small hexagons, stuff like that. You can also change how fast the pulse will go. So that just about does it. Thank you for watching, and I hope you watch what I do with my next project.